China has surpassed the United States in approaching the third known interstellar visitor. On October 3rd, Tianwen-1 China's Mars orbiter captured the first ever close-up images of 3I Atlas, and what they show defies everything we know about comets. It has no tail. From tens of millions of kilometers away, scientists can now study its delicate structures and motions, as well as its surface and composition, in unprecedented detail, unlocking rare clues about its origin and the ancient environment it has traversed. Humanity is staring directly at a cosmic relic that could hold secrets billions of years old. Tianwen-1 orbiter spotted foreground images of the object, but the expected features of a comet were absent. From a distance of approximately 29 million kilometers, close enough that a significant tail should have been clearly visible, the images revealed a faint glowing sphere with no tail whatsoever. But there is something else even more absurd here. Recent reports from NASA's Jet Propulsion Laboratory indicate that 3I Atlas exhibits non-gravitational acceleration, an unexpected change in its trajectory, both forward and sideways compared to pre-calculated paths. According to standard cometry physics, such acceleration should be accompanied by substantial outgassing. A natural comet would need to lose a significant fraction of its mass to generate this additional thrust. Renowned astrophysicist Avi Loeb has estimated that if Atlas were a natural comet, it would have to shed more than 13% of its total mass during the period of observed trajectory deviation. This mass loss manifesting as a bright coma and a dust tail pushed away by solar radiation pressure, and the solar wind is considered the most natural explanation for any extra acceleration in a conventional comet. However, no dust stream, no gaseous plume, and no indication of the massive outgassing that the calculations predicted. The stark discrepancy between theoretical expectations and observational evidence raises profound questions about the object's nature. To all my fellow skywatchers out there, can our basic theories still explain this object? The comment section is for your thoughts, no matter where in the world you're watching from. And if you love unraveling the mysteries of space, hit like and subscribe to join us on the next journey beyond the stars. And now, back to today's news. Tianwen-1's high-resolution imaging camera, originally designed to observe the Martian surface, was able to track this extremely fast-moving object at around 60 kilometers per second, relative to the Sun, providing humanity with the closest ever view. Despite the camera's precision and capability, 3I Atlas appeared as a simple blur, a featureless, luminous sphere. The China National Space Administration has taken the lead in revealing unprecedented details of Atlas, bringing the enigma of this interstellar visitor closer than ever to humanity's gaze. On November 6th, they released rare images showing a massive glowing core surrounded by a sprawling coma stretching thousands of kilometers across, and no familiar streak trailing behind, no cosmic banner fluttering through the void. This absence defies every expectation drawn from conventional comet physics and forces scientists to confront the limits of their knowledge. Its sheer size, unusual structure, and the unexpected behavior challenge long-held assumptions about what interstellar objects should look like. Researchers are now compelled to rethink the very models used to interpret fast-moving visitors from beyond our solar system. With Tianwen-1's unprecedented perspective, humanity has never been this close to witnessing a cosmic traveler that bends the rules of physics. The absence of a tail, despite the predicted outgassing required to produce the observed acceleration, suggests that the forces propelling the object may not be cometary in origin. It challenges the conventional understanding of interstellar visitors and raises the possibility of unknown, or artificial mechanisms behind its motion. We can understand that while all prior calculations suggested a comet should display a massive tail due to solar-driven outgassing, what Tianwen-1 captured defies those predictions. Atlas is accelerating as if it were a comet, yet visually it behaves as though it is not. The glaring absence of a tail, combined with precise measurements of its non-gravitational trajectory, creates a striking contrast between theory and observation. Humanity now faces an interstellar enigma, a fast-moving, accelerating object that refuses to conform to the rules of natural comets, leaving scientists grappling for explanations. Remember, during July and August 2025, this object did show a tail captured by the Very Large Telescope, but it was a gas jet pointing straight toward the Sun. And now that tail has vanished. The list of anomalies compiled meticulously by Professor Avi Loeb has grown to a perfect 10. A retrograde orbit close to the ecliptic plane, an unusual sun-facing jet, immense size and mass, an extraordinarily precise trajectory, abnormal nickel-ion composition, low water content, extreme light polarization alignment with the WOW signal, an intense blue hue, and now non-gravitational acceleration that cannot be explained by natural outgassing. Now, the question is the third interstellar object really natural? Scientists are racking their brains with the madness of the universe, trying to make sense of what they are witnessing. However, you know, the true gift from Tianwen-1 is not merely the surprise of a possible internal propulsion within 3I Atlas. What it offers is far more profound, a rare opportunity for scientists to observe an interstellar object in what may be its most pristine state. So luckily, the images reveal the nucleus and the faint early-stage coma largely untouched by the intense radiation and heat of the Sun. This allows researchers to study the object's raw structure, its light reflectivity, and its unaltered chemical composition before solar influences could significantly modify them. In essence, Tianwen-1 has provided a magnifying lens into the ancient face of a traveler, from beyond the star-sand unspoiled window into its origin and the conditions surrounding its parent system. Through high-resolution imaging and advanced spectroscopic analysis, scientists have already drawn astonishing conclusions. The data suggest that 3I Atlas is unimaginably old, dating back billions of years, possibly formed from the primordial debris of another stellar system long before the birth of our own solar system. Some analyses even propose that Atlas predates the Sun itself, having wandered the galaxy since the earliest epochs of the Milky Way's history. Spectroscopic data from Tianwen-1, combined with observations from the James Webb Space Telescope SphereX mission and several ground-based observatories, have begun to unveil its composition in unprecedented detail. The detected ratios of chemical compounds provide critical clues about the physical and chemical environment where Atlas originated. These elements point to a rare type of stellar nursery region where high-temperature processing and cosmic irradiation led to the creation of unusually pure, metal-rich materials. Such refinement is rarely observed in comets within our solar system, suggesting that Atlas may have formed under conditions radically different from anything familiar to us. A joint study by Belgian and American astronomers revealed clear evidence of long-term exposure to galactic cosmic rays. By analyzing spectral data from multiple telescopes, they discovered an abnormally high carbon dioxide to water ratio in the coma, approximately 8-1, a striking deviation from the ratios found in ordinary comets, which rarely exceed 1-1 or 2-1. This peculiar abundance immediately sparked debate. Several hypotheses emerged to explain it. One suggested that Atlas formed in a region of its original protoplanetary disk, where carbon dioxide could freeze more easily than water. Another proposed chemical transformation process within the disk, potentially driven by intense ultraviolet radiation. A third hypothesis centered on cosmic ray processing, an idea that soon gained traction as the most consistent with the available data. After extensive modeling and comparison with laboratory simulations, the research team concluded that 3I Atlas's outer shell has likely been processed by galactic cosmic rays over billions of years of interstellar travel. These high-energy particles could have gradually converted carbon monoxide on the surface into carbon dioxide, while also creating a thin weathered layer enriched with organic compounds. The result is that the current surface composition does not represent its original primordial state. Instead, it reflects the accumulated chemical scars of eons spent drifting through the galactic environment. To planetary scientists, this discovery is invaluable. For the first time, an interstellar visitor can be studied in a state that closely reflects the conditions of its early formation without being entirely reshaped by solar heat. Tianwen-1's data allow researchers to peer into the deep past of another planetary system, one that may have existed before our Sun ignited. Through its metallic composition and radiation-altered chemistry, 3I Atlas tells the story of a fragment from a long-lost world, a piece of cosmic history that survived billions of years of solitude between the stars. In many ways, the mission's images and spectra represent a time capsule from the infancy of the galaxy itself. And while its strange acceleration and lack of tail continue to puzzle researchers, the deeper chemical and structural revelations from Tianwen-1 have already begun to reshape how humanity perceives the life cycle of interstellar matter. Far from being a mere comet, Atlas stands as both a mystery and a messenger one, carrying within its weathered shell the memory of a world that existed before ours. At present, the visitor from the depths beyond our solar system is swiftly moving away from the blazing sun, never to return. The only remaining chance to observe it in greater detail will come on December 19, 2025, when 3I Atlas reaches its closest approach to Earth at a distance of about 270 million kilometers. After that, it will drift permanently into the dark, uncharted reaches of interstellar space. Whatever future discoveries await, they will all trace back to these first haunting glimpses of a visitor humanity may never see again. Thank you guys for watching till the end.